All right, good afternoon, everyone. At least on the East Coast here, coming to you live from our Gator studio in New Jersey. As usual, you've got me, Mike Huber, and today we've got Chris Morrissey, our Connecticut rep. So we're going to walk you through hybrid base today. It's a really trendy topic, isn't it?
Yeah, but is it fake news, Mike?
It is not fake news.
No.
So hybrid base, we think it's here to stay. It's definitely growing in popularity, and more and more contractors are starting to use it. But hey, we got a lot of people signed on. Why don't we poll our audience?
Yeah, let's see what everyone's using.
All right, so are you currently using hybrid base? Let's see what people say. Got people from across North America. I saw, Saskatoon and Nova Scotia. We got Texas, California, or even some people from your territory, right?
Saw some people from the Northeast. Thank you. Connecticut, Massachusetts.
All right, wow, pretty evenly split here. So we got people that are already using it and people that want to know about it and potentially give it a try.
Yeah, I said the over-under would be over 50%, and it looks like
just
I'm under.
Close. I think you didn't bet on that, right?
No, not a good idea.
So what is hybrid base, Chris? What are we talking about here for those 52% that haven't tried it yet?
For years and decades, people have been using aggregates that have a lot of fines in them. And moisture has always been kind of an issue. And we want to utilize a base material like a 3/4 stone that doesn't have any fines within. You can see on this image here. And then the bedding layer is even an aggregate that doesn't have any fines in.
Yep, so that clean stone brings some benefits to the table. It is going to be free draining. It allows water to pass through it. It is going to compact and consolidate easier. You don't have your piles freezing in those extreme ends of the season there. So a lot of different benefits to it. The whole idea, though, is that we want to make sure that we're using angular aggregates that don't have any fines in it. So that's very important.
Yep.
All right, so that's kind of the whole idea. You can see our model here. There's that 3/4 clean stone, and there is our 1/4 inch or number 9 chip stone as our setting bed. So that permeability, that ease of install, kind of extending your season, all great benefits to the hybrid base. But if you don't believe Chris and I, here's one of our contractors out in Illinois. He's a big proponent of hybrid base. So let's hear what he has to say.
Kyle Needham with Green Ridge Landscaping. Beautiful December day here in Southern Illinois. It has not been like this all week though. It has been raining. As you can see behind me, ground is slop. But we are still working thanks to our clean stone base open grade. We've been doing this for right about 6 years now. It has extended our seasons. It has simplified our install process because we're working with one type of aggregate rather than multiple types. Biggest thing to us, it poured down rain all day yesterday, and we're back on the job site today and made a lot of progress. Try doing that with crush and run.
There's a lot of dealers with bins full of crush and run that are crying after seeing that video, Chris.
Yeah, and Kyle's been doing this for a long time and has had tremendous success in all of his projects. So we thank you for that video, Kyle.
Yeah, getting back onto that project right after a rainstorm, you're not losing any time. So that's a huge benefit right there. So those aggregates, let's run through those a little bit closer, right? So we're talking about clean 3/4 stone and number 57 stone. You got some of that for us?
I got some. Let's pour some out.
Dump that out. Let's take a look. All right, so all that stone is angular in nature, right? That means that it's going to mesh together well, and it's going to kind of lock together. We're going to have very little fine particulate matter and dust, right? So that means that you have void space in between all that stone when it's installed. That void space allows water to percolate or permeate right through it. So I think we're all on the same page when it comes to that foundation material. Your base stone is going to be that clean 3/4 or 57 stone.
Yep. And next would be our bedding layer. And there's a couple different options. And primarily on the bedding layer, we'll probably see a 3/8 stone.
All right. So that's also known as a number 8 stone. So a number 8 stone or a 3/8 inch chip. You can see this is nice and angular in nature. Our largest size pieces are approximately 3/8 inch in diameter. And that's all going to mesh and lock together pretty nice and tight. And we're going to have that void space in there. But for a bedding layer, that's almost too much void space, Chris.
Yeah, particularly with the joining material and what you're going to utilize. We'll talk more on that afterwards.
So what are some other options for that setting bed material on hybrid base?
Well, we have a number 9 stone, which is essentially a 1/4 inch chip stone.
Okay, so that number 9 stone, much finer, smaller particles than the number 8 stone we just looked at.
Yep.
Now, what does that bring to the table?
Yeah, you're gonna have way less voids with this, but it's still gonna allow great permeability.
And it's a little bit easier to screed and level off. You get a more uniform surface than you will with that 3/8 inch chip or number 8 stone. The downside's the local availability. In some places, that 1/4 inch chip, this finer stone here that we're talking about, can be pretty difficult to find, and it's probably going to cost twice as much as that number 8 stone. So it will make your job site run a little bit smoother, but can be a little bit tough to find.
Yep. And just wanted to show you an example of another 1/4 inch chip that we're kind of seeing here and there, and that's this one right here.
Well, that one looks a little bit too round for my tastes in a hardscape project, Chris.
So in my world, they typically call this a pea stone, and as you just said, it's very round. So what's the difference between an angular stone and a round stone?
Well, sharp edges.
Sharp edges.
So that round stone isn't stable. It tends to roll and move. It doesn't lock and mesh together. It doesn't create a structurally sound setting bed to support your hardscape project. Those round stone are just always going to be unstable. Think about standing on a whole pile of marbles, right?
Right.
Doesn't work too well. That angular stone is what you want, so make sure you're checking with your supplier and getting an angular stone, whether that's a 3/8 inch stone, a number 8 stone, or a 1/4 inch chip, that number 9 stone.
Yep.
Pretty good stuff.
Yep.
All right, so we've got those aggregates pretty well dialed in, right? Yep. So let's take a look at our cross section again. You want to slide that over for me?
Yeah.
All right. So when we have this cross section, now obviously this is constrained by glass, but if we were to start pouring water on this, what do you think's going to happen, Chris?
I think it's going to permeate right through, Mike.
Let's pour our water on it. So we pour our water in here. Glug, glug, glug. Where's that water going?
It's going right down to the
Draining
bottom.
right down to the bottom. That's good.
It is, but it seems to be collecting at the bottom, Mike.
It's collecting at the bottom? Well, this is a glass fish tank. What do you expect
So
to
it's
happen,
impervious.
Chris? So when you have a hybrid base installation, sure, we all agree that clean stone without any fines in it is going to be completely free draining. It's going to allow the water to pass right through it. And that's fantastic. But as that water passes through that clean stone, we need to make sure that that water can evacuate from the bottom of our hardscape project. If we just created a swimming pool, not so good for the long-term performance of our hardscape project. We're basically, destroying that benefit of that free draining clean stone.
Yeah. Anything in full saturation is just going to weaken over time.
So short of, contractors that like to install hardscape projects in a fish tank, what are some other reasons why your base may not drain well?
Well, the subsoil conditions.
Okay,
can
so
be an
soils,
issue.
right?
Yeah.
You could have sandy, gravelly soils that drain very well. You could have clay soils that don't drain at all, or some silty soils that don't drain at all. So if you have poor draining soils, you got to think a little bit. You got to come up with a way for that water to evacuate from your project. And, that might include some exfiltration piping. Your other concern, even if you have those well-draining soils, is the fabric that you choose. So, we had a contractor, he went out, he was gung-ho. This was his first hybrid base install job. He put about 30 tons of crushed stone into this driveway. He thought it was going to be free draining. First rainstorm, he found out that it wasn't free draining. So you just did not have that drainage. You did not have that water flowing through and evacuating from the job site. So we're in New Jersey. You get freeze-thaw cycles. What do you think would happen if that all froze, Chris?
You'd start to get some movement.
Yep, you get some frost heaves, some freeze-thaw movement, exactly what you're trying to avoid by using all that clean stone. So in that case, that was in New Jersey. Probably some sandy soils, and they used the wrong fabric there. So what are we talking about with fabrics, Chris?
So a couple options, for strength purposes, we have woven textiles.
All right, so woven fabric, that's what we see here. That's kind of that nylon-looking material. It's shiny, feels like plastic, and that is strong, right? No arguments there.
Yep.
Problem is, it really doesn't drain. So I'm going to pour some water on top of that. We got our water in here. And as our water sits on top, well, it doesn't go anywhere, Chris. That water's sitting on top of that fabric. You might as well put a blue tarp underneath your hardscape project.
Yeah, it's not going to drain all that free.
All right. Last week, we got called out. Someone said, hey, woven fabrics may drain better if you put aggregate on top and it's in contact with the soils below, right?
Yeah.
You ever hear that claim?
Yeah, I've heard it quite a bit, actually. It comes up often whenever we're talking about the different fabrics that we would utilize in each project. And there are some people doing demonstrations out there with aggregate on top of a suspended woven textile, and water does go through with all the weight from the aggregate on.
All right, so I'm trying to push on that fabric. I've got some stone on top. We're getting a little bit to go through,
Yeah.
right? A couple drops.
A little bit.
All right, so it is permeable, but it is
Yes.
not very permeable. So let's compare that to our non-woven fabric. So our non-woven fabric that you see here is more of a felt-like material, right? It's softer to the touch, looks more like felt. And as I pour water over top of this, well, what happens, Chris?
It goes right through.
It goes right through, so don't have to have any aggregate on top. It is draining very well.
Yeah, this is a drainable fabric, you know, it's utilized in those applications, but this still has a significant amount of strength. So it still can be utilized in pedestrian walkways and patios and even some light residential.
Right, so you're talking about two fabrics that both serve that separation purpose equally well, right? Separating our native soils from our aggregate. That woven fabric is a little bit stronger, but you don't need that strength in a residential hardscape project. That GF 4.4 non-woven fabric is plenty strong and provides fantastic drainage.
Yeah.
You know, let's relate that to you know, kind of a real-world situation here. You know, everybody's got kids that go out and play in the backyard with squirt guns. They spray each other. Well, hey, that's kind of like the water that can flow through the GF5, those squirt guns.
Yeah.
You got some protesters getting sprayed with a fire hose. You know, that's the kind of water that can go through the GF 4.4.
Yeah.
So we want that high water flow to happen.
We want it out quickly.
You take a look at our spec sheet. Our spec sheet on the GF5 shows that you're getting 5 gallons per minute per square foot through the GF5 using those kind of laboratory type conditions. And that is basically aiming a fire hose at the fabric and spraying it through. Now the GF 4.4 has 135 gallons per minute per square foot. So what would you choose to have underneath your project, Chris?
Significant amount more, so I take the non-woven textile.
I would go for that non-woven textile almost all the time, unless I really had substandard soils. So, you know, you have horrible clay soils, things that you know are going to move. You need that reinforcement of that GF5, or you have clay soils you know aren't going to accept any water anyway.
Yep.
We use that woven fabric. What do we need to do, Chris?
You're going to need to evacuate the water somehow, so we use exfiltration pipe.
Exfiltration pipe.
Yep.
So we're going to put some pipe underneath our hardscape project in that clean stone, right?
Yep. Typically on your subsoil, once you're done excavating, you want your subsoil to be pitched in a direction away from a foundation, you know, where it can kind of pool up and collect, and that's where you would be putting your exfiltration pipe. Now, if you see on the overhead view here, there are holes drilled into this pipe. Now, you wouldn't want this upright. You'd almost want it upside down, so as the water level rises, it's able to collect in the pipe and gradually make its way off the project.
So looking at our you know, iPad here, we got a view of basically a hybrid-based cross-section and an exfiltration pipe. So as our water comes down through the system or in through the sides of the system, water always gets into a hardscape project. Whether you've got polymeric sand in the joints or nitro or a clean chip, you're always going to get water in there, and we need to make sure that we allow means for water to get out. So that's that pipe, going to gather up that water, and we're going to take it somewhere else, whether that's a drain to daylight, a dry well, somewhere where that water can go so it's not underneath our paver project.
Yeah.
And as Chris mentioned, you know, on a hybrid base install, you have to pay more attention to your initial excavation, to that subsoil. We want to make sure that it pitches, right?
Yeah.
You don't have any areas where water can puddle or pond underneath your project and stay wet all the time. So pitch that off. Same way that you pitch off the finished surface, pitch it off to make sure that your pipe drains and get that water out of there.
Yep.
All right. So that's kind of the idea. Free draining is a great feature and a great benefit to hybrid base, but the reality is if you've got substandard soils, you use the wrong fabric, you can take that free draining system and turn it into a bathtub. You know, backing water up under your project, it's going to cause problems for it down the road.
Yep.
All right. So I've got another poll question for the audience, Chris. Should we ask them?
All right, so for your compaction method, There's been a misconception in the industry. We want to see what everybody's heard out there and what you're doing. When you're using a clean 3/4 stone or 57, is there a necessity to compact it?
So the claim is 3/4 clean stone is self-compacting. As you dump it out of the wheelbarrow, dump it out of the skid steer bucket, it is going to basically consolidate itself by falling, and you don't need to run that compactor. All right. Well, I like that. We've got almost 80% of the audience that's saying that that is false.
It is.
And it is indeed false,
It is false.
right? Clean stone requires less compaction, but it doesn't require no compaction. So the claim that clean stone, number 57 stone, is 95% Proctor density dumped out of a wheelbarrow or a skid steer bucket is definitely false. We did a little demonstration in our lab. We filled up this bucket with stone. We just tapped it on the ground a few times, right? We didn't vibrate it. We didn't let it sit for 10 or 15 years and move on its own. But as we tap that, you can see it consolidates quite a bit as those angular particles seek to mesh together and lock together and kind of minimize some of that void space. If you built a patio in your backyard and 6 months later it settled an inch or two, how do you think your wife would feel about that?
My wife would be upset, but if I was getting paid for the job, I think my homeowner would be very upset.
Right. Well, I don't know which one's worse, but you need to compact and consolidate your stone. So sure, clean stone allows you to do thicker lifts with the same equipment. You know, you can definitely consolidate that clean stone much faster than your modified stone. So that's an advantage, but make sure that you are adding some kind of compaction or consolidation.
Yep.
All right. So another idea with that base material is that when you have your modified stone and all of those small particles, you've compacted it to 95 or 98% Proctor density, you've driven out a lot of that void space, all those particles are tightly meshed together, that friction hold is very strong, keeping those particles from moving. But with that clean stone, the tendency for that stone to move laterally is much higher than a well-compacted modified stone because of that void space and because of the potential, I guess the lack of friction hold that is occurring there.
Yeah. Well, we got an option.
We got an option? Well, we got a good demonstration to show it, right?
Yeah. Let's show the demo.
All right, so here you see one of our studio models standing on top of a column of clean stone. Pull away the sides, that column of clean stone moves laterally, and our model falls down. When we reinforce it with grid, though, what happens?
Stays right up.
Wow. That grid has prevented that stone from moving laterally. Now, you're not seeing the collapse of that aggregate, that sideways movement. Grid's a great option for any type of hybrid base install, whether it's pedestrian or vehicular.
Now let me ask you, Mike, there was a bunch of grid in that demonstration, just to show the strength. Let's just say you were doing a driveway 8 to 10, 12 inches of aggregate. How many pieces of geotextile would you put in between?
I'd say that a good rule of thumb is just to put one layer of geotextile. Well, you'd put a geofabric on the bottom, of course,
Sure,
right?
yeah.
And then one layer of geogrid right in the middle of your aggregate base.
Okay.
So if it's 6 inches, put it at 3 inches. If you're doing a driveway and it's 12 inches, put it at 6.
6 inches.
Have it
Okay.
right in the middle to help reinforce that structure.
Cheap insurance.
Very cheap insurance. It's going to greatly increase the stability and long-term performance of that clean stone base. You just want to eliminate that tendency for it to move laterally, and the geogrid, all those little boxes, really do a great job of restraining that movement.
Yep.
All right. So let's see. We've got some questions rolling in. Has anyone used this in a commercial application or larger than a driveway? Well, I'm pretty sure that there are jobs going in as we speak that are certainly large in square footage and large in potential usage. So hybrid base can really perform in any kind of application, whether that's a walkway in a backyard, a commercial plaza, or even a parking lot.
Yep. And a lot of hybrid base or clean stone installs stem from permeable spec projects by engineers/architects. And we kind of dumbed it down for the everyday residential use, but evacuation of water is the key goal here and works very well in those applications. We're bringing them down to these, where those commercial jobs are very large, larger than those typical driveways and residential jobs.
Right, and that's a good point. This is really kind of evolved from permeable pavers, and permeable paver jobs have been installed for decades and certainly large-scale applications like parking lots and streets, and they're all performing very well as long as some attention has been paid to the details, of getting that water out and reinforcing the structure using fabrics and geotextiles.
Yep.
All right, so don't normal pavers laid on CR6 and sand shed 80 to 90% of the water anyway, as per ICPI specs? So if you install pavers and you put polymeric sand in the joints, certainly, almost all of that water is running off of the project. But where is that water running off to? Well, that water is running right off the edge of the project to that area where you just disturbed the soils, where you put your base versus the native soils. So water always gets into your base material somehow. Water's always going to work its way in. Water's always going to come in from the top, from the sides, from groundwater. You're always going to have some water in there.
Yeah, and on the fabrics, we are wrapping up the sides of the base material. That doesn't mean that it's impervious from water to go into the side. So it can find its way in there. It can migrate down.
We're going to move on. We've got the idea of compaction pretty well hammered in, right? So once we have our base material well compacted, we screed off our setting bed layer. Now we're going to install our pavers, and we need to prevent our pavers from moving laterally, right? We need an edge restraint. So can I go get the plastic edge and spikes for you, Chris?
Unfortunately, we can't use plastic edge and spikes because of the aggregates not having a lot of fines and that friction hold not being there. Spikes won't really lock into anything for all that well. It might work for a month or two, but as soon as you start to get some water in and out, it's going to start to move around. And
or even load on top.
Yeah.
Those spikes, they'll push sideways very easily. They just can't grab into that 3/4 clean stone. So we've got two great options for you. One is an aluminum edge with a wider spike, so you can see it on screen there. That's going to provide that resistance to movement, right? You can't push that wider spike laterally against the aggregate there. So, hey, it's a great option. It's a little bit more expensive than plastic edging, but having a successful job is certainly worth the cost there. The other option is the Gator Extreme Edge, Chris. So Gator Extreme Edge is the fiber reinforced, polymer modified, incredibly strong concrete edge restraint that you can get from your Alliance dealers. And that's going to do a fantastic job on hybrid base because it's going to kind of mesh into that clean 3/4 and prevent movement.
Yep, and it slightly bonds to the paver as well. So there's been a lot of misconception of it being pulled away eventually. It actually kind of locks in nicely. But it's also very cost effective. I know you guys out there in the contractor world, material costs can add up, but Extreme Edge is going to be a great option for you compared to some of the other options.
All right. You got a little sample there to show everybody?
I do. We have a paver with Extreme Edge attached to it, and it's kind of locked in, as you see. And usually the Extreme Edge will actually go into the bedding layer, which would be even further down. It would be about an inch below this underneath, so the paver would sit on it like a shelf. But even as it is now, you can't break this apart.
All right. So we're going to show you a quick video on the Extreme Edge, and we're going to jump into a live demonstration after that. All right, so that Extreme Edge looked pretty easy to use, didn't it?
It's very easy to use, Mike.
I always thought concrete edge would take a lot longer than plastic edge. I was always a plastic edge guy, but you can really do them about the same speed once you get used to it. It's pretty cool. A bag of Extreme Edge is 50 pounds, easy to mix up with a ½ gallon of water. And how much coverage do we get out of a 50-pound bag?
Usually around 15 linear feet.
So that's about 2 sticks of edge, right?
Yep.
All right. So, Chris, you want to start mixing up that Extreme Edge for us?
Yep.
So it is very important to use 1/2 gallon of water to that 50-pound bag of Extreme Edge. That's going to give you that high strength. We made this polymer modified to make that easier to mix up, lower that water cement ratio. We're actually hitting over 12,000 PSI in our lab testing, which is pretty cool. You know, that's incredibly strong. Regular bag of concrete's maybe 3,000 or 4,000 psi. Extreme Edge is way beyond that. So you're building a hardscape project, you want it to last for decades, Extreme Edge is going to give you that performance. Now, that aggregate in there is pretty small, right? It's a number 9 stone, it's a granite chip.
Yep, we're using that same number 9 stone in which we showed you for an option for a bedding layer. Hand this to you.
All right, so if you take a look at this close-up photo, we've got the aggregate. You can see that small aggregate. You can see the fibers in there. Let's see if we get that photo up. All right, so there's our aggregate, there's our fibers. You know, the aggregate's nice and small, gives you high strength, and makes it very easy to work with. And those fibers are, they're something special, Chris. They're not a regular concrete reinforcement fiber, are they?
Right, you'll normally see like a monofilament, meaning a singular strand of a piece of plastic, where this is more of a, almost like a mesh once it's all mixed together, and gives you almost like an internal lattice within the Extreme Edge.
Right, that fiber is going to expand and kind of branch out as you mix this up, and that way it's well distributed, forming a great reinforcement structure in the Extreme Edge.
Yep.
So with any hardscape edging, whether it's plastic, aluminum, or concrete, we need to remove the bedding layer, right? We don't want that edge to sit on top of the bedding layer, which is not as stable as our base material. So we remove the bedding material and pull that away from the pavers. And as we pull that away, well, you can see we've kind of developed a little bit of a gap underneath the pavers, which is not a problem because we're going to pack that full of Extreme Edge, kind of creating a shelf there.
Yeah, we really want that. You know, we want the pavers to be sitting kind of on top of the Extreme Edge. Cohesively, it'll bond, you know, attach itself to the paver, but also rest on it.
All right, so I'm putting some of this in here, Chris. How high up the paver do we need to go?
For a 2 3/8 paver, which is most common, 60 mil paver, we're going to go up about an inch.
All right, so an inch. What if we have a thinner material? What do we do?
Thinner material, such as like a natural stone or a tile, we're going to go up halfway.
Right, so make sure we're coming up at least half the height on that material, and it's the strength and the small aggregates of Extreme Edge that allow you to keep that so low. So now, very easy to backfill and grow grass right up to the edge. You know, it's not going to become exposed quite as much as you will with the typical concrete edge that's kind of towed all the way up to the surface there. So fantastic option for your hybrid base, fantastic option for any hardscape project, but it really does shine with the hybrid base application.
Yep.
All right. So that's our Extreme Edge. You know, it's high strength, fiber reinforced, polymer modified, and fast setting. You know, really does a great job there in terms of working for your hardscape edge. So let's pull this off the table here, and let's get set up for our nitro demo. So nitro, what are we talking about? We're talking about a pretty cool resin-based joining material. So that nitro is going to, you know, give us a slightly different option for hybrid base. And why do we need that different option, Chris?
You know, this is going to be permeable. That's probably one of the main benefits of it. So it allows water to go through your hybrid base and off the project.
Yep, and then the setting bed materials that we talked about earlier are also very important.
Yep.
So we talked about that number 8 stone, that 3/8 inch chip, and how it's got kind of a lot of void space. And that comes into play when we're choosing our joint material. Yep. So let's see, this 3/8 inch stone, right? We've got a good visual on that here. If you take that 3/8 inch stone and you put polymeric sand on top of it, we all know that you have to vibrate and consolidate your polymeric sand in the joints. So as we vibrate and consolidate our polymeric sand, where is it going?
It's going right to the bottom.
Uh-oh. We just lost all the polymeric sand in our joints. It filled up all the void space in that 3/8 inch aggregate. That is definitely a problem. If you don't compact and activated that polymeric sand, well, over time, all that material on the bottom is going to migrate into that chip stone. You're going to be left with a crust of polymeric sand supported by nothing.
Yep, you're going to have way less longevity out of it.
So we've got two problems, right? If you do compact as you're supposed to, you might lose all of your polymeric sand. It might never choke off and back up. And if you don't compact, you're going to be left with a crust of polymeric sand supported by nothing, and that's going to give you a problem as well. So with that number 9 stone, right, that 1/4 inch chip, it's going to deal, I guess, much better with that polymeric sand, right? As we put that polymeric sand on top of our number 9 stone, you can see tapping it Well, it doesn't go down quite the same way. That chokes off. It blocks off all those void spaces much faster and much easier. And we can successfully install our polymeric sand on a number 9 stone with minimal effort, minimal extra effort compared to a traditional install.
Listen, polymeric sand is not cheap, so if you're utilizing like a 3/8 stone compared to a 1/4 inch stone, you got to keep that in mind. But nitro seems to be a pretty good option.
All right, so nitro. What are we talking about here? We've gone back to our number 8 stone, our 3/8 inch aggregate, right? It has the larger void spaces.
Yep.
But we're going to use nitro, which is our resin-based air-cured joining sand. It's pre-mixed with that resin with the binder from the factory. Comes in a bag of wet material, and it's a little bit stickier and gummier than a polymeric sand, free-flowing granular polymeric sand is. So nitro goes in. We compacting?
Don't need a compact nitro.
Wow, you don't need to compact nitro, so there's a benefit. But even if we did tap it a few times, well, that nitro is really not migrating downwards, right?
No,
it's
very
kind
little.
of bridging those void spaces, and nitro is going to chemically cure with exposure to oxygen. So unlike polymeric sands, which form a crust supported by densely packed material underneath, that nitro is going to harden up from top to bottom with exposure to the air. It's never going to settle down into that void space. It's never going to migrate. It's going to work great for these hybrid base applications. So if you're doing a hybrid base application, I would definitely consider nitro, especially if you're using that number 8 stone or 3/8 inch aggregate underneath as your setting bed. All right. So permeability. We're talking about permeability with nitro. Polymeric sands are effectively impermeable. But with our Gator Nitro, we can pour water right through it. It's going to flow right through very nicely. Oh, look at that.
Almost instantly, Mike.
Almost instantly. So while water does flow through it, it's not really meant for a true engineered permeable job where you want to put in a number 9 stone in the joints. This is great for hybrid base, though. They're designed to be semi-permeable, right? We'll let that water through, let it through that clean stone, let it either percolate into the native soils or get piped off through a drain to daylight, and our whole project will dry out faster. It's going to keep the pavers drier, the joints drier, and you'll end up with a better performing system.
Yep.
All right. Should we do a quick nitro demo?
Let's do it.
All right, so one key difference between nitro and polymeric sand is the fact that it comes in a pail pre-mixed, right? This is a wet material, and it cures with exposure to oxygen, as we talked about.
Yep, so nitrogen is actually what keeps the oxygen from getting to it. So not only is it infused with the product, then put into the bag, then the bucket is also infused with nitrogen just so you have more longevity if it sits on a shelf for a while.
All right, so you take this bag and you slice it open on your pavers, right?
Yeah, let's do it right now.
Not so fast.
Come on.
We have to wet the surface down. The resin, the glue that binds nitro together, well, it wants to stick to things. It wants to stick to your paver or stone surface. So we need to wet that surface down to protect it from any staining. It will actually repel the glue, Chris. That's pretty cool, isn't it?
Yeah. So, but also with that, you might have seating walls, you might have fire pits, everything really needs to be sprayed down.
All right, so we'll wet our pavers down. Let's wet the stone here. We got everything nice and wet. Now we can cut open our bag,
Now
right?
we can open it. Yep. And with this material, you're kind of working bucket to bucket. You're not opening up an entire pallet, and opening up and spreading it out, because it's going to be hard to kind of control the water. If it's really hot out, things can start to dry out. So work bucket to bucket as you need.
Yep, you'll see that the installation process is very easy and very quick with this wide joint. We've probably got a 3/4 inch wide joint. I'm going to spray down my tools here. We're going to use a squeegee on here, but you could use a broom if you had a smaller and a rougher textured surface. So with nitro, it's a great 2-person install, 1 person on the hose, 1 person on the broom or squeegee, and you can see how easily that falls right in the joints there.
Yep.
So very, very quick install on a wide joint here, but what happens on a tight joint, Chris?
Tighter joints are a little bit more difficult just because of the resin. It kind of gets a little bit more clumpy than, say, a polymeric sand that's dry. So I think the tightest joint width we'd ever want to use this on is a 3/16 joint.
Yep, so you need to have at least a 3/16 inch wide joint. So you got to make sure that your paver has a wide enough joint in order to use Gator Nitro. So that might be a limitation as far as, hey, tight joint pavers, your historical Holland stone 6x6, 6x9s, you cannot use a resin-based joining product like nitro in those joints. Maximum joint width is 2 inches.
2 inches.
Yep. And minimum joint depth is 1 inch. So we've got our nitro installed here. You can see in that close-up how permeable it is. So that water just drains right in, right? Soaks right in through the nitro. That's pretty cool as it sucks down. Now, the Gator Nitro that we spread across the surface, well, I have a pile left at the end of my install, right?
Yep.
Throw it away?
Yeah, toss it.
No, don't toss it. It's expensive stuff. No, it's not.
Yeah.
But we want to save that to use on another project, right? So we can scoop that back up, throw it in the bucket, cover it with water to protect it from oxygen, and you're going to be able to use it for another 3 or 4 weeks. You know, that water kind of keeps it from activating and hardening up.
Can't do that with polysand.
Well, polysand's kind of all dirty and dusty once you get it off a job, so you can definitely save that nitro and use it on a future project. So, you know, nitro is a fantastic option, you know, mainly because of that choking off phenomenon. If you're using number 8 stones, you're either going to use a lot more polymeric sand or just have an ongoing issue over time. So use that nitro for some of these hybrid base installs as long as you have a wide enough joint. Resin-based product, you know, hardens up from top to bottom. It's almost closer in performance to a mortar than a polymeric sand.
Yep.
All right. Any questions rolling in? Anything that we will answer live here for you guys? So do nitro joint profiles stay permeable over time? Well, nothing lasts forever, does it, Chris?
No, it really depends on the scenario. You know, if you're under a whole bunch of trees, you're going to have a lot of sediment over time. They can get clogged up.
Yep, you know, the whole idea of a true permeable installation is to have that number 9 or 1/4 inch chip in the joints so that as it clogs up, you can remove it and reinstall clean material. You know, Gator Nitro, it's tough stuff. You're not removing it to reinstall it to make it permeable again, but you can pressure wash it. It's so tough that you can pressure wash it after 28 days. So you can kind of maintain that permeability by rinsing it, you know, as required and flushing it through and getting that dust, dirt, debris, organic material cleaned off. Again, you know, not really meant for a true engineered permeable job, but it does work great for these hybrid base installs. All right.
Got anything else up here?
Any other questions that we've got here? What are your recommendations for hybrid base with a heating element? Well, that's an interesting one. You know, that would kind of go back to your heating element manufacturer. When you install heated paving, you're either doing electricity, you know, electric heating element mats, or you're doing hydronic heating elements. And with the hybrid base, you have 2 concerns. So one, that having that angular chip that could potentially puncture your heating element tubes if they're hydronic, or, you know, puncture the insulation of your electrical tubes. The other potential issue is that when you install that heating element, you want it to be in full contact with your setting bed material in order to transfer that heat energy to that and then up to the pavers. If you have void space, which you definitely have in that clean chip, that can cause problems. One, with the transfer of that heat energy, and 2, with your electrical heating elements potentially overheating and burning themselves out. So I would definitely check with your installers on that heating element. Another thing that you may find, though, is that the hybrid base actually, you know, almost melts snow off faster than a traditional base. All right, anything else? Any other questions we've got? You guys talk a lot about freezing. I'm from South Florida, and we have never seen stone bases here. It is the 1/4. Is the 1/4 hybrid base still a valid option? Well, Florida is kind of a market that's different than anywhere else in the world, Chris.
I'd say so.
You've got, you know, your coarse, sandy, granular soils that drain well. In many cases, you're not doing the 6-8 inches of base that we are here in the northern states or in Canada for a walkway or a patio. You're only doing a couple inches of base. So sure, a hybrid base could still be 100% a worthwhile option, but maybe it's not quite as thick. You know, maybe you're doing 4 inches of your 3/4 clean stone and then your chip stone. You know, kind of going to depend on your local aggregates, but you still have the fact that it requires less compaction. You know, your ease of screeding out and leveling those layers, and the free draining nature. While you don't have freeze-thaw cycles, water is the enemy of every hardscape project. So it helps to lubricate particles and cause settlement in the absence of actual freeze-thaw cycles. So having a well-draining system is a benefit no matter where you are in the country or the world, for that matter.
Yeah, they get a lot of rain, so they'll experience a lot of erosion. So
exactly. You know, getting that water to be able to pass through and in a well-designed system infiltrate the soils or drain to daylight would be a fantastic option.
yeah.
All right. Any other questions out there? How soon after installing Extreme Edge can you install G2 or Nitro? What do you say, Chris?
This is a good question. This is a good question. So for the poly sand, you could pretty much do it right after.
Yep.
Yep.
Polymeric sand, you know, go ahead, do your installation right after getting your Extreme Edge installed. That water that you use to activate the polymeric sand isn't going to cause any problems for the Extreme Edge.
Yep. However, with the nitro, you're using a significant amount of water to get it pushed into the joints. So that could ultimately affect the Extreme Edge on the side, especially if it started to pool right around the edging restraint.
Right. It's probably not going to really affect the structural integrity of the Extreme Edge, but it could wash a lot of the cement paste off the surface. So your best bet's to wait 4 or 6 hours after installing that Extreme Edge. Let it set up a little bit, and then go ahead and do your nitro install.
Yeah.
All right. What else do we have? Is there a better stone? Granite, bluestone, sandstone, better for base and bedding? Well, of course there is. Typically, the harder your stone, the better it's going to last and perform as a foundation material. So, you know, your basalts, you know, the very heavy stones are certainly less subject to breaking down over time with any kind of movement or compaction. You know, your sandstones and limestones may not be quite as dense and strong, but obviously you can only work with the aggregates that are available locally in your area. So, you know, using the proper fabric or grid reinforcement, no matter what your stone is, can help level the playing field and make sure your project performs well for years to come. All right. I think that just about wraps up the questions there, Chris. You know, the whole idea of hybrid base is that it has some advantages over a traditional crushed stone and sand setting bed install, mainly revolving around that free draining nature, you know, the speed and efficiency of installation, being able to work a little bit earlier in the spring and later into the fall because your aggregate piles aren't freezing, your job site's not freezing up, you know, so that overall efficiency of the job site can increase. Let's just make sure that we sit there and say, hey, I'm digging a hole in the ground and this hole is going to fill up with water. So where is that water going to go and how is it going to get out? You know, that's really the key question with a hybrid base.
Yeah, it's a growing trend in our industry. It is not fake news. It's going to get bigger and bigger. More people are going to utilize.
All right. Well, we appreciate you joining us today. You know, next week we're doing a show on Gator Base. You know, that's something that a lot of people thought was fake news when it first launched, but it is not. Gator Base has been around for 10 years now. We're going to walk through a Gator Base install and compare it to a side-by-side test project that we built 8 years ago, where we did a traditional ICPI installation and a Gator Base installation. You know, show you the progress, show you the results 8 years later. I think you'll be impressed at how well Gator Base has done.
It's all good stuff.
All right. Have a great day, everybody. We will see you next time.
Thank you.